and toothpaste is actually space-friendly. However, when it comes to cleaning themselves, things can get rather difficult. They can't ever really take a bath or use normal shampoo. Most astronauts have a cleaning kit for those purposes. If you enjoyed it, make sure to leave it a thumbs up and subscribe to our channel for more videos like this one. See you in the next one.
The Voyager 1 space probe is the most distant man-made object from Earth. It has traveled so far that it isn't even in our solar system anymore. But even in the vast emptiness of space, Voyager 1 recently detected something truly astounding. You are watching Matter. In this video, we'll discuss the strange sounds that Voyager 1 heard emanating from deep space. On September 5th, 1977, a Titan IIIe rocket blasted from Cape Canaveral. The rocket's payload was a Voyager 1 spacecraft. 2 years later, in 1979, Voyager 1 flew past Jupiter, getting a boost in speed from the planet's incredible gravitational field. As it flew past, it captured new, high-resolution images of Jupiter and its strange moons. In 1980, Voyager 1 reached Saturn, the final destination of its primary mission. Voyager 1's trajectory around Saturn had been adjusted in order to perform a flyby of the moon Titan. This flyby pushed the spacecraft's trajectory below the south pole of Saturn, which in turn tossed Voyager up and out of the plane of the solar system. Its planetary science mission was over, since encounters with other planets would no longer be possible, but the gravitational slingshot maneuvers around Jupiter and Saturn put Voyager 1 onto an escape trajectory out of the solar system. In 2012, a full 35 years after its launch, Voyager 1 reached the edge of the Sun's sphere of influence, becoming the very first artificial object to have ever left the solar system and pass into interstellar space. Astonishingly, more than 4 decades after it left Earth, the Voyager 1 probe is still operational. It is still sending back data from the very furthest edges of explored space at a rate of 16 bits per second. To compare, typical internet upload speeds today are at least 50 million times faster, but Voyager 1 is transmitting from more than 14 billion miles away and getting 325 million miles further every year. So, sending data across that much space is certainly not an easy task. For nearly the past decade, Voyager 1 has been traversing the cold, lonely wilderness beyond our solar system. But outer space, despite what the name might suggest, isn't entirely empty. Not quite. The interstellar medium, the stuff that exists in the space between stars, is made up of a very thin smattering of molecules and charged particles, an average of less than 1 particle per cubic centimeter. Just as the particles of air in our atmosphere carry vibrations that we hear as sound, the tenuous plasma of the interstellar medium can also carry vibrations, albeit much, much weaker. Voyager 1 has two 30-foot antennae that stick out from one side of the spacecraft, which are part of an instrument called a plasma wave system. These antennae are the ears that Voyager uses to listen in on what's going on by measuring subtle variations in the tenuous plasma around the spacecraft. It turns out that in space, Voyager can actually hear something screaming. In 2012, Voyager heard its first sounds from interstellar space, a brief, relatively high-pitched whistle. A second whistle was heard around 6 months later. These interstellar noises correlate with sudden bursts of activity happening in the Sun, which creates rippling in the interstellar medium like rocks dropped in a pond. These shockwaves are useful because the frequency of the sounds can allow astronomers to estimate the density of the medium that Voyager is flying through. Stella Ocker, an astronomer at Cornell University, says that these screams from outer space have only been seen about once a year. So, relying on these kinds of fortuitous events meant that our map of the density of interstellar space was kind of sparse. So, while these periodic flares of sound from the Sun are helpful, they only offer a short glimpse into what is really going on. In order to get a complete idea of the nature of the interstellar medium, astronomers really need to know what is hiding between those bursts. To get a better picture, Ocker's team set out to fill those gaps. They used Voyager's plasma wave system to try and get a continuous measurement of the interstellar medium. Earlier this year, they finally succeeded. The Cornell team announced in May 2021 that Voyager 1 has heard a very faint, low-frequency hum coming from deep interstellar space. Ocker describes the signal as very faint and monotone. The sound may be faint, but it is consistent. Another team member, James Cords, describes it like a quiet or gentle rain. In the case of a solar outburst, it's like detecting a lightning burst in a thunderstorm, and then it's back to a gentle rain. This background noise vibrates around 3 kHz, but Ocker notes that over time we do hear it change, but the way the frequency moves around tells us how the density is changing. This is really exciting because we are able to regularly sample the density over a very long stretch of space, the longest stretch of space that we have so far. This provides us with the most complete map of the density of the interstellar medium as seen by the Voyager. The new data show that the interstellar medium's density began to increase around 2013 and reached a peak near 2015. It seems to have mostly stabilized for now, with an electron density of around 0.1 particles per cubic centimeter. So what exactly is causing the vacuum of outer space to hum? The answer isn't exactly clear, but thanks to Voyager and the Cornell team, it's becoming a little clearer. They're calling this phenomenon plasma wave emission. The prevailing theory is that the continuous humming is caused by the vibration of the thermally excited particles themselves within the interstellar plasma. Hopefully, with continued observations of the interstellar medium, astronomers will be able to shed some more light on this odd noise. Voyager 1's nuclear power source has kept it alive for significantly longer than its original mission, but it's expected to only last for a few more years. Voyager might finally go silent as early as 2025. Stella Ocker said of Voyager, "Scientifically, this research is quite a feat. It's a testament to the amazing Voyager spacecraft. It's the engineering gift to science that keeps on giving." Already, Voyager 1 and its twin, Voyager 2, have given astronomers an invaluable amount of new scientific knowledge, and now the knowledge even extends beyond the reaches of our solar system. Up until now, astronomers have had to rely on the guesswork and computer simulations to figure out what the space around our star is like. But thanks to these newly discovered cosmic sounds, Voyager 1 can listen to how the interstellar medium is moving and changing in real time. As long as it continues to operate, that little probe will be able to offer even more fascinating insights into the nature of the unexplored cosmos. Thank you for watching. If you enjoyed the video, make sure to like and subscribe to the channel for more fascinating discoveries about our universe.
We now know more about the Sun than ever before thanks to space agencies like NASA and the ESA. And more recently, astronomers managed to capture this crazy phenomenon that happens on the Sun all the time. In this video, we'll be going through that and some other crazy facts about the Sun. Solar storms. Solar storms are strange disturbances within the Sun's atmosphere that can sometimes have devastating effects on the Earth's climate, as well as the solar system in general. Scientists have been trying to figure out whether it's an increase in solar storms that's causing temperatures on Earth to rise rapidly over the past few decades. It's believed that the frequency of these solar storms is increasing as the Sun evolves further, and that it may just change the way the solar system functions. There are many different kinds of solar storms, such as solar flares that you've probably heard of. When it comes to the effect solar storms can have on the solar system in general, solar flares are probably the least intensive. Solar flares are sudden bursts of brightness caused by disturbances in the Sun. They happen very close to the Sun and most of the time are hard to detect. Even the most powerful solar flares are barely detectable, let alone by the human eye. There's another type of solar storm that usually follows solar flares, and that's coronal mass ejection, or CME. Unlike solar flares that usually happen around the Sun's surface, CMEs are a leak out of the Sun's corona. It's when a significant amount of plasma being produced by the Sun ends up finding a crack and making its way out of the Sun's atmosphere. Hence the same coronal mass ejection. Some CMEs can be so large that they can even collide with the Earth's magnetosphere. This is known as a geomagnetic storm. The last time something like that happened was in the 1800s, and it nearly destroyed the newly created telegraph system that was vital for long-distance communication on Earth. CMEs lead to the creation of coronal clouds, which some people confuse with the CME itself. Some of the most interesting solar storms that NASA has actually managed to capture are called solar particle events. It's when all these tiny little solar particles collectively become aggravated during a solar event, such as the ones we just mentioned, and they create this incredible formation that can be considered something similar to an aurora, but on the Sun. In fact, when these solar winds end up colliding with the Earth's magnetic field, they actually do create the auroras here as well. NASA's TRACE satellite managed to capture this event on camera once, and so far it's the only picture of a solar particle event actually happening. The size and evolution of the Sun. As pretty much all of us already know, the Sun is the largest object in our solar system. It's the central object that all of the planets in our solar system orbit around, and it's one of the very few things we can actually see clearly from space. 99.8% of all of the mass in our solar system belongs to the Sun alone, which can give you an idea of simply how massive this star is. In fact, if the Sun was just a hollow ball, you could fit over 1 million Earths inside of it, as crazy as it may sound. But on the grand scale of things, the Sun actually isn't that big. For thousands of years, humans thought that the Sun was the largest object in the entire universe. However, as science progressed and we eventually discovered brand new galaxies and even planets beyond our solar system and the Milky Way, that theory was disproven rather quickly. We now know about absolutely massive stars and objects that absolutely dwarf the Sun, even if that may sound incomprehensible to most of us. The Stephenson 2-18 star is the largest known star in the universe, and it has a radius that is over 2,100 times the radius of the Sun. If the Sun was placed right next to the Stephenson 2-18 star, you would barely even notice it. But despite it being small when compared to other stars, it's still hard to deny that the Sun is absolutely massive, but that's just temporary. The Sun, much like all other objects in the universe, is constantly evolving. The Sun is getting brighter and brighter over time. In approximately 1.5 billion years from now, the Sun will be 10% brighter than it is today. In 3.5 billion years, it will be over 40% brighter. This will in turn make the planets that orbit the Sun even hotter, and the Earth might start to resemble something more similar to what Venus is now, a real-life hell. But this doesn't really explain how the Sun will change in size. Well, as the Sun keeps getting brighter, it'll eventually enter what is known as its red giant phase. This is when a star gets so bright that all of the hydrogen in its core becomes exhausted, causing the Sun's core to heat up and expand rapidly. The Sun will start to get more of a red hue compared to its more yellow or orange hue currently, and it will get so large that the entire area where Mercury, Venus, and even the Earth are located within now will all be occupied by the Sun. However, scientists don't predict that the Sun will actually eat up these planets, but rather that they will shift their orbit further. At the end of the red giant phase, the Sun will enter stellar evolution. This will be when stellar winds start to collide with the Sun, and the Sun will begin to lose massive amounts of mass at once. Eventually, the Sun will be so small that it'll be comparable in size to the Earth and will turn into what is known as a white dwarf star. And it may be the end of our solar system as we know it. The Sun is going to change drastically over time, but that won't be happening until the Sun is at least 10 billion years old. As of right now, the Sun is in the middle of its life cycle and is around 4.59 billion years old. Other Sun facts. You might think that the Sun is simply a burning ball of fire, and to be fair, you'd be technically correct in that assessment. But there are a lot more layers to the Sun than simply that. What we see of the Sun is called the photosphere. This is the part of the Sun that is on fire, with an average temperature of around 6,000 degrees. Beneath that layer is the convective zone where temperatures are significantly lower, but it's hard to actually tell what the temperature of this layer is. However, once you get even deeper into the Sun's core, the temperatures once again pick up steam and can reach up to 13.6 million degrees. Another interesting fact about the Sun that you might not already know about is that different parts of the Sun actually rotate at different speeds. That may sound strange or even impossible, but it's important to understand that the Sun is a star and nothing like any planet like the Earth or Mars. The Sun is essentially a giant sphere of hydrogen gas, and the parts of the Sun near its equator are actually moving faster than the parts of the Sun near its poles. The Sun's insides are also moving at different speeds than its outside. What's truly crazy is that you can actually see this phenomenon happen by looking at the movement of the sunspots on it. We are only going to know more about the Sun as numerous missions from NASA and other space agencies mature. The Solar and Heliospheric Observatory that was built in a collaboration between NASA and the ESA has already taken so many incredible snapshots of the Sun already since it was first launched in 1995. NASA also sent the Stereo spacecraft into space to study the way the Sun works in 2006, rather than simply just take pictures of it. The Stereo spacecraft managed to give astronomers a 3D perspective of the Sun, and it taught it a lot more about the weather system in our solar system. More recently, NASA and the ESA have entered another collaboration with their Solar Orbiter project. This spacecraft was launched in February of 2020 and is expected to begin its mission by orbiting around the Sun in November of 2021. Despite the mission not even beginning yet, the Solar Orbiter has already managed to capture images of the Sun's surface, including the closest image of the Sun ever taken. And only time will tell what other amazing images it is set to capture. And that's a wrap for this video. If you enjoyed it, make sure to leave us a like and subscribe to our channel for more videos like this. See you next time.
Could you imagine life on a planet so hot that the atmosphere